Hey, welcome back. And so today our topic will be arrays. So let's get started. So let's create a test class. Let's create our main method, all right? And let's create a variable for each day of the week, okay? Actually, I already have this down pat, all right? Let's look at this for a second. So we have Monday to Sunday. So we have 7 variables, okay? We have 7 different variables to store each day of the week. Monday for Monday, Tuesday for Tuesday, and so forth, right? And this is actually really inefficient. So how would you store like all of them in one variable? How would you? It's something called a data structure, which can hold 0 or more elements. And an element in this case is either a object or a primitive type. So you can have a data structure full of integers, as in type int. You can have data structures full of animal objects. You can have data structures full of strings. Like in this example, we're going to work with a string array. All right. So we're going to talk about data structures today, and they're actually a crucial part of programming, not just in Java, but in every single language. And without data structures, really languages would be not powerful at all. You wouldn't be able to do a lot of stuff without data structures. For example, if you have a company and you store data for each customer, and each customer has a list of all the favorite movies they have. For example, Netflix, right? You want to see like all the movies that person watched. That if you store them each in one variable, you would have millions of variables, right, for each customer, because eventually they have so many movies they watch that it just adds up, right? And same thing for like the list of the favorite movies. So like if they like a movie, right, they have like a like list and a dislike list. Each one would be like tons of variables if each movie they liked or disliked was a separate variable. But if you store each one in data structure, so you have a list of movies that a person likes or a list of movies a person doesn't like, right, then you can kind of store in one structure. Okay, so data structures are a key component of programming, not just in Java, but every language. So, like I said before, so data structure is something that holds data, right? It holds 0 or more elements, which can be objects, spelled objects wrong, or primitive objects, primitive types, sorry. Big typo there. So they can be either objects or primitive types. Okay, they can either be like, for example, a string, like an object, or they can be an int, or they can be an animal, like an array of animals or a list of animals. But the first data structure we're going to work with is an array, which is the most basic type of data structure in Java, okay? So let's get started with arrays. So instead of having, for example, a variable to store each day of the week, okay, as a string, let's create a string array, okay? So string array, we're going to call it days of the week, all right? We're going to say equals new string array, and we actually can pass it in right here. So we can say Monday, Tuesday, and so forth. And let's just do this. Let's just copy and paste this time. Thursday. Oops. Friday. Oh man. Can't even copy and paste correctly. Saturday. And finally, Sunday. The reason I'm copying and pasting incorrectly because I'm rushing it right now. But alright, so we have an array of 7. So this array has 7 elements. And the most important thing to learn about arrays is that when you go through an array, the first element is 0. So Monday is stored at index 0. So we call the position it's stored at as an index. So this is index 0, right? Tuesday is stored at index 1 and so forth. But so basically Sunday is stored at index 6, right? Because the length of the array is 7, but the index starts at 0. So 0, 1, 2, 3, 4, 5, and 6. Okay? That's very important to know. Not just in arrays, but every data structure starts at 0. Okay? It's just the way that languages are implemented, they decided that it's better to start at 0. There's less off by 1 errors, believe it or not, than it would be if it starts at 1. Just the way math works. All right. Now, so what can we do with this array? We can actually print out each value of the week. So we can do for int I equals 0. Remember, we started at 0, right? I is less than days of the week dot length, so we can get the length of the array, right, by just doing dot length here. So this is a function in an array to get the length of the array. I plus plus, like a regular for loop, but we're starting at 0 and ending at when it hits 6, because I is less than 7, right? So, and then we're going to print out each element. So we're going to do, it's going to be confusing, but days of the week, left bracket, I, right bracket. So in other words, we're printing out whatever I is. So days of the week. So actually, let's do an example first. This makes more sense. So if you print out, for example, Monday, we do days of the week 0, right? Because the index is 0. This is how you print out the first day of the week, okay? And actually, let's debug this after to actually see how it's storing it. But if we print out days of the week 0, we get Monday. If we print out days of the week 6, right, we get Sunday. Okay, because again, this is a 6th index, right? So it starts at 0, ends at 6. We get Sunday. If we print out 7, we're going to get an error because it's out of bounds. So the bound is the min and the max. If it's less than 0, or if it's greater than the max, which is 6, it's going to throw an error, right? It's going to say out of bounds exception, index out of bounds, right? Index 7 is out of bounds for length 7. So length, if the index is greater than length minus 1, so in this case 7 minus 1, which is 6, if it's greater than 6, it's going to throw an index out of bounds exception. It's very important. This is a very common error when you first start out. If you get this error, it's common because a lot of people have that off by 1 logic is kind of hard to figure out. At first, it's hard to get used to the fact that it starts at 0. So if you get this error, it just means that you're off by 1, or off by more than 1, but you're off by at least 1, okay? In this case, we're off by 1. Because if we, for example, put in 70, now we're off by 64. So just because it doesn't mean you're always off by 1. It could be more than 1. It could be less than 1. It could be like, you could put a -1 here, right? There's actually a warning here, though. It's saying it's out of bounds. Right, so IntelliJ actually tells you you're out of bounds. If you put in 7 again, it tells you you're out of bounds. So even the IntelliJ is already aware of how big this array size is. So it actually tells you, like now it's 6, there's no error because you're actually in bounds, okay? You're actually between 0 and 6. All right, so let's actually debug this and see what's going on, like how Java stores this array, okay? How does it work? All right, so we have our variables here. Let's actually delete these and start over because we won't need these anymore. But just to show you that it's very inefficient to have 7 variables for the days of the week instead of just have 1 now. You have 1 variable instead of 7, right? So this is why data structure is so powerful. All right, just one example why. All right, so let's go ahead and step over this, and now we can see that. Okay, 0 has Monday, 1 has Tuesday, right? And this is actually how it's, so it actually converts strings to bytes in the background. Everything gets converted to bytes, so don't worry about the value, okay? It looks weird. The value in human terms is Monday, okay? So the first value is Monday, second value is Tuesday, and so forth until we get to Sunday, okay? So in other words, this is working the way we want it, all right? If we print out this, right, again, we get Sunday because we're printing out the 6th index, okay? So let's get to a more serious example, and let's print out each value. So instead of days of the week, passing in 0 to 6, we actually just go through I, right? Basically, all this loop is going through is 0 to 6. It's just going to basically print out 0 to 6. But we actually want to pass in 0 to 6 for our days of the week array. Right, this is going to get the value, okay? So if you run this again, we should print out Monday to Sunday, okay? Oh, interesting. Oh, because I was like, why are we printing Sunday twice? Well, because we're still printing it out here. Okay. Well, some people might argue that Sunday is the first day of the week, but actually it is technically. But I think Monday is the first day of the week because that's the way the work schedule works. But anyway, so we have Monday to Sunday. All right, so we printed out all the values in an array, and now we're gonna do something a little easier. It's called a for each loop, and it only works with objects. So in this case, the string is an object, so we can, instead of doing this, right, we can do this instead. We can do string day colon days of the week, and then just print out day. So now you don't have to worry about having to do this, right? Like you don't have to worry about I or any variables because automatically. So what this for each loop does is when you loop through objects, right? If you loop through objects in a data structure, for example, you loop through this data structure, which is a data structure of objects because it's the data structure of strings, string array, then you can use a for each loop to loop through it. So let's go ahead and loop this again. This is a nicer way of doing this. Now, in a lot of cases, you actually might need to worry about the index. For example, if you're trying to get the position of where, for example, if you're trying to see okay, which index is Friday. So like in this example, it doesn't really make sense, but an example where you have a list of, let's say you have a list of pizzas, and you're trying to see each value is unique, right? And the order is the order of the list or array is the first element is the first order, and the last element is the last index. So you're trying to get the middle order, like you're trying to get the, let's say, the middle customer. So you have 100 customers, you're trying to get the 50th customer, and you want to use the index to get, like, you know, pizza orders, and then you pass in 49 for the 50th orders. So if you want to access a specific element, then you would use something like this. Okay, you would actually have to use int I equals 0. But if you don't, and this is an easier way of doing it, use a for each loop. Okay, so let's have a nicer example. Now, instead of using strings, let's use animals again. So let's actually do some more polymorphism examples. So let's go ahead and we still have our animal classes, and if you don't, just recreate them. I'm just going to put them on the screen first so you can create them quickly. So we have our animal object. Go ahead and pause the video if you don't have it and just recreate it real quick. We have our cheetah object. All right. We have our monkey object. And we have our snail object. Okay. So now what we're going to do is we're going to create an array of animals. Okay. So we're going to do animal array. Again, option return to auto imports. We say animals equals new animal. And another way to instantiate an array is you can pass in number of the length. Instead of passing the values like here, you can say new cheetah, right? And then now you have an array of size 1. Instead of doing this, you can just specify, okay, I want an array of size 5. Right, so I'm going to say animals 0 equals cheetah. New cheetah, right? This is the same thing as, and then you just do, let's just do both to see the difference, okay? Let's do this one first. So we have animals 1, 2, 3, and 4, because their size is 5, right? So it's 0 to 4. Now we're going to create we're going to create a array of 5 cheetahs, right? And the same thing as this, okay? Other way to create, and actually, I'm just going to call it. Other way to create an array by populating it when instantiating the array. Just like I did before with the number of days, we can actually just use squiggly braces to create an array of size 5. So we don't actually need this. We just do this. And let's just do this 4 more times. Oops. All right, so now this is the same thing as this, because instead of you setting each value later on, so sometimes you don't know what the values are, so you do this, right? You don't know what the animals are in an array. You're creating an array, and you don't know what they're going to be yet, right? Okay, so, but in this case you do, all right? So if you do know what elements are going to be in this array, then you go ahead and do it this way. You instantiate the array and you populate it in one line, right? So let's go ahead and do the second one, because in this case we do know what we're going to do. We're going to have a cheetah, we're going to have a monkey, and we're actually just going to have, whoops. And we're going to have a snail. So we're just going to have 3 animals. Actually, we're going to have 2 cheetahs, but let's just have just 1 cheetah, 1 monkey, and 1 snail, right? Let's just keep it simple. All right, so now, by the way, naming a variable animals too is really bad naming convention. I just did it because I'm trying to be quick. All right, but anyway, so now we can use our for each loop. So we can say for animal, right? A animals, and we can just print out a dot get position. You can also print out the animal type. So animal plus a dot get class dot get name. This is how to get the class name. Okay. This is kind of annoying. Okay. So we're gonna print out the animal's name. It's animal plus their class dot get name plus position. Right? And let's go ahead and run this. We should get their position. So a snail is going to move 1. Oh, actually, we forgot to do a.move. Whoops. Okay. And by the way, when you print out the name, it's going to have the package too, unfortunately. So now we do a.move, and it's actually going to move, right? So now we can see the position is 50. So cheetah moved 50. The monkey moved 10 spots or spaces, and the snail only moved 1 space. So this is another example of polymorphism, because we have an animal array, and each animal is a different type. It's a different subclass, a different child class of animal, right? And we're actually mimicking polymorphism because we have different types of animals in this array, and we are actually this function does something differently for each one, right? So when you call a.move, right, we print out the animal, okay? Then we actually get the positions. That's pretty cool, right? So dynamically at runtime, we're actually figuring out that, okay, the animal moving is a cheetah, and then it's a monkey, and then it's a snail, right? So we can also do this the old-fashioned way with the int I equals 0, and say I is less than animals dot length. And again, we start at 0 because the first index is 0, right? So this is 0, this is 1, this is 2. So the size is 3. So the last index is always length minus 1. Remember that. So it's 0, 1, 2. Always start at 0. So if the length is 3, the last index is 2. So easy to remember that way. Okay. Anyways, I++, just do animal I dot move. So this is another way of doing it, right? Just the old-fashioned way, and just print it out again. But now you just do, well, actually, you want to go ahead and do this. Oh, this is long. See how more annoying this is? Like, so much easier just doing this, because we don't have to actually specify, we don't care about the index, we just want to print out every animal and also have them move each time before we print it out, right? So it's a lot easier doing the for each loop. Let's just run it again. We should get the same exact thing, all right? We should get what we got last time, and we do. All right, so again, this works also, but this is a preferred way for cases where you don't care about the index, you don't care about accessing the indexes. All right. And finally, let's just do a non-object example for array. So let's create a array of objects. Okay, so array of integers that are randomly generated. Okay, so let's create our random generated again. Private static final random rand. We can call it R, we can call it random, whatever. We can call it rand equals new random. All right, and we're gonna say. All right, so we're gonna create a nums or lottery numbers. Okay, equals new int array, and we're gonna say that there's, I think it's 4 numbers plus a special number for like the Mega Millions, but let's just say size is 5, right? Let's just say it's 5. Let's say 4. Let's generate 5 numbers. So for int I equals 0, I is less than lottery numbers at length, I plus plus. We're gonna say. So we haven't generated our numbers yet, so we're just gonna loop through. We're gonna create them in this for loop actually, right? So we're gonna say lottery numbers I equals rand dot next int, and we're gonna pass in a min and a max. So let's say the min number is, I don't know what the min number for lottery number is, but let's say it's 1, and the max one, for example, is, let's say it's 100. I don't know. Okay, so we're gonna say max minus min plus 1 minus min. Okay. Oh, sorry, it's plus min. Keep making the same mistake. All right. So it's max minus min plus 1 plus min. Okay. Then we print out lottery number I. Okay. And now we're creating our variable. We're creating our element in our array, and we're also printing it out each time we create it. Okay. Or we could just do this instead. Just to show you that it actually is creating that element. And just say lottery numbers, is that lottery number? Okay, so in this example we do need to use int I equals 0 because we have to actually access the index to create it. So in cases where you have to actually populate the array individually, like in this case from you have to populate all 5 starting at 0 to 4, index 0 to index 4, you have to do int I equals 0, right? We can actually print it out in the same for loop. We're going to print out a separate for loop just to show you that after it's created, we have the array, right? And it's going to be populated all the way through. Okay. So in this example, we're just printing it out, so we don't have to use int I equals 0. We already can access it using the for each loop. Okay. So let's go ahead and do this, and we should get 5 random numbers between 1 to 100, and we do 95, 49, 50, 97, 50. 95. Also, you can see we have duplicate numbers, so we can actually check if it's already been created. So if the number has already been assigned to the array, we can go ahead and try again and generate another random number, but that's not necessary. If there was a real lottery number class, we're trying to generate lottery numbers for real, then you would do that. So we'd do something like the thing is, you would have to check. Okay, you have to check the whole list or the whole array each time. That's very inefficient. So there's other data structures that are better than this to do this. So we're gonna actually come back to this example and make it more efficient so that there's no duplicates. Okay, and that way we actually can mimic what the lottery number system does, right? It generates 5 random numbers. I don't know what the range is. I don't know if it's 1 to 100, but it will be similar to this example, but instead of using an array, we're using a different data structure that is very, very good at handling duplicates and checking for duplicates. So it's not an array. Array is actually very slow at handling duplicates, because every time we want to check if the number is already an array, we have to go through the whole array and say, okay, for example, let's go through that example. So we insert 95, okay, and the next time we insert a number, we say, okay, is 49 equal to 95? To know that, we have to go through the array of size 1 and say, okay, it's not 95, so we go ahead and insert 49. Then we check if it's not 95 or 49, so we loop through the array again, and there's only 2 elements. So now we check, okay, is 50 not 95? Yes. Is 50 not 49? Yes. Then we do the same thing again. 97, is 97 not 95? Yes. It's not 49? Yes. Not 50? Yes. And finally, is 95 not 95? No, it is 95. Therefore, it's duplicate. Go ahead and try again. And then you try again. You have to try one more time. Is it duplicate? Yes or no? So there's extra logic to do this, to make sure that there's no duplicate elements in your array. Okay. So an array is not a good data structure to use if you're trying to make sure you have no duplicates, in other words. But it is a useful data structure because A, it's the simplest data structure, so it's good to learn, and also it's used to create other data structures. For example, the next data structure we're going to work on is called a array list, and it's just a dynamic array. So an example, in this array, you always have to specify the size, so it's not dynamic. So if you want to make this, let's say, size 6, you can't. You have to copy it to your array and then make sure that your array has an extra space, an extra element that it can hold. So let me just write this down. So arrays are data structures that are fixed in size. They are not dynamic. So if you create an array of size 5, you can't change the size. Okay. But if you use another data structure such as an array list, right, you can. So basically, an array list uses an array as one of its attributes, and it has an integer attribute called intSize to modify the size. So every time the size fills up, it adds more space to it. So you can implement an array list, and we'll be doing that actually in not the next lesson, maybe the lesson afterwards. I'm not sure which lesson it will be, but one of the future lessons, we're going to implement our own array list and see how that works. So if you want to use a dynamic array, you can use a array list. It's actually like this, array list, all right, which we'll be creating and looking at in a future lesson. All right, so that's it for this lesson. Thank you so much for watching, and we'll see you soon.